Now the same chi-test, or chi-squared test is what it's actually called. Oh, what I forgot to do I tell you this in a minute? Hang on. Oh yeah, I'm going to tell you how it works in a minute. Okay, so that can be used with a variety of different applications, because what it does is it compares expected values with observed values. So you can actually do other things like comparing if you got sort of several things on different days and you want to know, could that be equal every day, or is there something different about Fridays or whatever? You could set up a uniform distribution where you've got the same number every day and you compare the actual values and see if that's significantly different. I haven't taught that one this year, and there was also one we used to do with M&Ms where you compare the proportion that the company says is of different colours, and then you take your packet of M&Ms and you count up your colours and you see how they are, and you see whether what you've got is what would have happened if the colours actually were as they say. Okay. So, it can be used for different things. So in Lecture 4.1, we looked at the idea of independence. And so chi-squared's looking at independence, but rather than just saying, is it different, it's saying, is there enough evidence that it's different? So that's the difference. So, and there were two aspects, urgency and size were not independent. We decided that there was a relationship between them. Because of the non-urgent jobs, so here's non-urgent, 300 over 400, 3/4 of them were small, but for the urgent jobs, 0.43 were small. And so you can see those two numbers there are a long way apart, so clearly there is a difference. But if that was